We're going to pick up after spring break with experimental design. Now you've finished working on your proposals for the most part in terms of the lit review. Now we're going to shift towards, well, when you're trying to think about the methodology you're going to use, what are the approaches that you have? We've talked about the difference between quantitative and qualitative. But if you're going to do a quantitative study, you will be likely conducting some kind of experiment. Now, experiments can range in a great number of different variations. But what we're going to be talking about are just a couple of the classic or broadest categories. So a brief outline of what we're going to be covering. We're going to talk about true experiments. We'll talk about threats to internal and external validity and how true experiments really address a lot of these things, or the good ones do. We'll talk about pre-experimental, quasi-experimental, causal-comparative, and single-subject designs, as well as some general ideas about confounds in experiments. And then we'll talk about an evaluative framework at the end that I'm going to want you to apply to an article that I give you, and then you're going to share that back out with the rest of the class. Hooray! Everyone loves that kind of assignment. So, if we think about a classic experiment, I'm sure you've all heard about the Bobo doll experiment that was the basis for social learning theory that emerged in the 60s, right? You had different kids watching people interact with this Bobo doll, and the kids would imitate it. And they varied it between aggressive and non-aggressive role models, right? They thought that gender might play a role, so the aggressive people had a female model and a male model, and they had 6 boys and 6 girls in each category. 6 boys, 6 girls, 6 boys, 6 girls, 6 boys, 6 girls, right? Female, male, non-aggressive, and then 24 control groups as well. Children that did not watch a model, that just went in to play with the doll. Now, this is a really good setup in a lot of ways, and we're going to talk about some of the characteristics that it has that are so good. When we think about the essential characteristics of what makes a true experiment, there are a couple things that they have in common. One, there should be random assignment to the different intervention or in different treatments. 2, you need to observe some kind of data, typically over time, but not always. And then the last thing is that you have to manipulate something. So you have to determine who gets what manipulation. And you have to do it in a random, not an intentional or purposive manner. So when we think about how the author Creswell talks about this, he talks about these 4 types of qualities. One is causal relativity, meaning that I want to be able to compare the effects of different causes, meaning my manipulations, which is number 2. I need to be able to control something in the environment, and I want to control it really well. And this is a big difference between doing research in a lab, where you have all kinds of control, and doing research in the applied world, where you have very little control. And I've done it in both. And research in the real world, or applied research, is way harder to do. And it typically doesn't give you as clean of results where you can really think about causal relationships unless you have a ton of control over that natural environment. Third thing is temporal ordering, meaning that I have some observations over time so I can note a change. I typically want to establish a baseline and then a post-test after the intervention. I want to do that over time, both for the control group and the experimental group. And when we go back to our true experimental designs, this is really the first one, right? And I randomize people into each one of my groups. The X means that I'm manipulating something with this group. No X here means this is the control group. I observe both at one and note whatever I want to about them, whether it's their academic achievement, anxiety levels, right? Social agreeableness, ability to self-regulate, I'm not sure. But I observe my dependent variable, whatever that is, after I randomly assign them. Then I manipulate something for one group and don't do it for the other, and then I look to see how they've changed, or if they've changed, right? And I compare the group that received the manipulation to the group that didn't. When I think about control of confounding variables, which is the fourth thing, I'm thinking about all related or relevant variables that might impact my dependent variable, right? So I may think, like if we go back to the Bandura experiment, I may think that gender has something to do with it. So I'm going to design my study so that I essentially wipe gender out by having both the models be balanced and the subjects be balanced across this important variable. I probably think that this has something to do with age too. And so if you think back to the experiment, they didn't do adults and children, right? They just talked about kids in a certain age range as being open to this social learning idea, or social modeling, if we want to be more specific. In some cases, though, when we go back to that time in the control, right, randomization gets rid of a lot of the confounding variables. Like if I did randomly assign people into one group or another in the Bobo experiment, I'd probably get close to half boys and half girls, especially if I had larger samples. But because I have so many different conditions here, right, I have one big condition over here, plus 4 here, plus 4 here, that's 9. If I wanted to get 30 people in this, I'd have to have 270 subjects, and that's a lot. These days, you might be required, but back then, that was a lot. So randomization gets rid of a lot of my confounds. I give my treatment. Now, in some cases, I may not want to observe them initially. And this is the case, say, if I'm testing math ability or your skill level on a specific task, because sometimes putting you through that pretest, especially if you have to do something, is going to impact your post-test. So right, if I want to see how long it takes you to solve a puzzle, giving you a puzzle to solve and clocking how long it takes you before I give you some kind of intervention, it's going to cue your mind and it's going to affect how you perform on the post-test. So sometimes, either by design or because I think there's going to be a problem with the pretest, I just look at the post-test. Give somebody an intervention, see what happens. Don't give the other group the intervention and see what happens with them. Now, that's not as good because I don't get to look at the change, because there's going to be a ton of difference in this group and in this group within each group that's going to kind of water down my results. So what I can do is the Solomon 4 group study, where I look at the top version and I look at the bottom version, and then I compare the differences between group 1 and 2 with what I see with groups 3 and 4. And that way I can figure out, did it matter that I exposed people to the dependent variable manipulation, or I should say measure first? Or is the difference that I see between groups 1 and 2 the same as the difference that I see between groups 3 and 4? And those are some confounds that we're going to be talking about in a little bit. So a longer list, or a more detailed list of the different characteristics, we have random assignment. And again, this is slightly different than random selection. Random selection means that everybody in the population that I care about, all 5 and 6-year-olds, for example, have an equal chance of being selected to be in my study. Once I have randomly selected people, now I should randomly assign them to the different experimental conditions, right? And so there's a slight difference. The idea is the same in that I don't want to get a biased sample, but each one of these is an important step in the overall process. The second thing is control over confounding variables. So when we talk about extraneous variables, we just mean any variable that we're not measuring directly to test our hypothesis, right? It's not our IV, or independent variable. It's not our DV, or dependent variable. So there are other variables that are important and they influence the outcome of the experiment, but they're not really part of the manipulation. I can do this either by designing my research to balance across things like gender and age and propensities towards substance abuse or things like that, or I can keep track of those things statistically and then ultimately add them into any analysis that I do. And we'll talk about these ideas in a little more detail later on. Manipulations, again, are what you do to each group. Outcome measures are the things, the dependent variables that I'm trying to figure out whether or not my manipulation actually impacts. And then when I talk about group comparisons, it means that I'm looking at all the different groups that I have. Now, a lot of basic research just has two groups, people who get one treatment and people who don't. Other studies, let's say a medical study, for example, might have 10 different groups, right? I have my control group who doesn't get anything. I have my placebo group who gets a placebo. It's not, say, the drug, but it looks like the drug and they're told they got the drug. And this is a measure to see what the placebo effect actually is when I compare them to the group that were told and did not get anything, right? Then I might have my medication groups who get the medication, but that might be separated into multiple groups. One receives, say, 10 milligrams, a second group receives 20, a third group receives 30. Now I could split those different dosages into additional categories where I talk about how often the drug is taken. And so maybe for each 10 milligram group, for each dosage, I say looking at the 10 milligram group, I say that group 1A is going to take the drug once a week, group B takes it twice a week, and group C takes it daily. And I do that for each of the dosages. And so that ends up with 9 different drug conditions, plus a placebo, plus my control, for a total of 11 groups. I may want to see whether or not medications interact with each other, and so I may combine medications. I may want to know whether medications plus therapy or dietary changes also change, and so I can expand my groups into as many as I really want to. But ultimately, what I need to do is make my group comparisons. The final thing is threats to validity, meaning that I need to think about whether or not the conclusions that I draw between causality and generalizability are warranted. Are they of high quality? And when I say causality, right, I'm trying to prove, does my manipulation actually impact the dependent variable? And if I make a lot of controls, I can make that claim. If I randomize, if I control for the placebo effect and any other factors that might threaten the validity, I can say that one thing causes a change in my dependent variable. When I talk about generalizability, I mean, is it okay for me to say that what is true in my study will be true of everyone? I've mentioned in medical research, for example, that most of the research is done on men and never on pregnant women. And so when we talk about the effects of drugs, side effects of drugs, the longevity of the effects of drugs, and so on, historically, and this has changed in recent years, it's been done on men, right? And as far as medications go towards pregnant women, there's so little research on that you really have to be careful if you are going to have a child about the types of medications that you expose yourself to, because it is likely that even though it is deemed safe, it probably wasn't tried on a bunch of pregnant women, because the threat or the potential damage that could be done to a developing fetus is too great. So the author goes into a little more detail on some of these things. Here's just an illustration of the difference between random selection and random assignment. When we talk about confounds and covariates, the graphic that's provided in the text is something that we've talked about before, where the circles represent the different types of shared variance, right? And that when we account for shared variance between different variables, we change basically our analytic approach. So I may realize that two variables, my dependent variable and my covariate, are very closely related, and so I may want to account for my covariate. And then I look at the relationship between my independent variable and what is left. So I would actually kind of parse out this and just have this left in my dependent variable. It's important to think about because a lot of times we end up getting correlations between things that aren't really related, and people misuse it and infer causality when really causality does not exist. A classic example is the idea between ice cream consumption and snake bites. Now, in some cases like this, it's clear that these two things are not really related to each other, right? There's another variable called the weather, right, that probably influences the behavior of both things, right? In the winter, you have fewer people going out to get ice cream. You also have fewer snake bites because snakes are hibernating, at least if you're in the north like we are. Then in the summer, when the temperature gets warmer, people go get ice cream a lot more, and the number of snake bites get up because 1, snakes are actually out, and 2, people are spending more time in the outdoors in general, right? In other cases, we find that this is not as easy to describe. So example, some research has talked about different parenting styles, like authoritative, authoritarian, permissive, and so on, and the impact that it has on how kids develop in terms of their personality. And you might find that research has indicated that authoritarian, or people who are, kind of the militant type parents, have kids who actually act out more, have more severe behavior problems, and so on. And it's easy to think that the causal relationship goes from the parenting style towards the child's behavior. However, it could be that really difficult children cause parents to become more authoritarian, right? That you need to set harder limits when you have a kid who's always testing those limits. You need to not reason with your kid because they're just pulling your chain and trying to manipulate you. And so the parenting style might actually be a function to some degree of the type of child that you have. And it is difficult to figure out which one of those things is truth and how much of one goes into the other, because it is a cyclical relationship. Another way to think about getting rid of confounds is by matching, and this is something that was done in the Bobo experiment, right? That if I think that boys and girls are somehow different in my dependent variable, or my manipulation might affect them differently, I want to make sure that I have an equal number of boys and girls in each condition. And so in my experimental group, I'm going to randomly select from my boys and girls and try to get as close to an equal number as I can. And then my control group, I'm going to do the same thing. Now, when we think about what a summary of different elements are to developing an experimental procedure, 1, you have to define your independent variable and your dependent variable. 2, you need to map out the manipulation, considering what is the time frame or the timeline. How long is this going to go on? How many observations are you going to make? What types of measures are you going to include? You're going to think about the treatments and exactly what type of manipulation are you going to use? How might you vary it across different groups? And are you going to have a control and as a placebo group, something that you think you might need? Finally, you'll think about your controls. How am I going to make sure that other variables aren't getting in the way of me seeing what I want to see? And I don't mean that in the sense that I want to confirm my own hypotheses, but I want to see the effect that a manipulation, whether it's therapy, a discussion, or a drug, has on future behavior. And I want to compare that across different groups. And so I have to think about what are the potential things that might get in the way. Maybe the time that I administer in, the day of the week, right? The peer groups that surround, socioeconomic status, parental income, all sorts of things that I might want to keep track of. So when I make my statistical comparisons, I can factor some of those things in to make sure that they are not having an undue influence on the things that I want. Now, when we talk about true experimental designs, the gold standard these days is a pre-test, post-test, double-blind, randomized control group with matched pairs. And see, I have matched choice there. How about that? In this case, we are talking about Pre-test, post-test, meaning I want to get a baseline established for everyone, give them the manipulation, and then see what happens. When I say double-blind, I mean that the experimenters don't know which condition they're looking at when they're grading or rating or making judgments, and the participants don't know what they're in. And so in that drug trial condition I talked about earlier, right, I shouldn't know if I'm getting the placebo or the 10, 20, or 30 milligrams, right? If I do, that's probably going to affect how I act and influence the placebo effect that might occur. When I say randomized control group, I mean that, right, people are randomly assigned to different conditions, and I do have a control group. And that's not just the sugar pill. It's usually, in these cases of medicine, it's a group that doesn't get an intervention at all. In the case of education or counseling or special education, right, I don't need typically a placebo because I'm not giving some kind of brain juice kind of thing that kids are going to drink and make them smarter or better behaved or less depressed. I am typically going to do some kind of intervention that helps with the behavior, with the thought patterns, or with addiction, right? And I want to see whether or not that happens. And so I'm going to compare the results of the people who get the intervention with the people who don't. A lot of times that just means I look at regular data. We'll talk in some case about some of the threats that if I don't give an intervention to everyone and the intervention seems like it's going to be good, I might have some additional threats that I need to figure out how I'm going to get around. And that's what the double blind will get around, but we'll get to that in a bit. The match pairs part also reduces the amount of variability that exists within each group. So for example, say I have, right, a weight loss drug that I want to try and see if it works on different people. One of the things that I probably want to control between my placebo control and experimental treatment group is the initial weight and the initial metabolic rate and the initial diet of all my participants. And so I would want to make sure that within each of those three groups, my control group, my placebo group, and my experimental group, I have people who are matched on those different variables. People who have a certain percentage of body weight should be represented in each group. People who have a certain type of diet and certain types of diets should be equally represented in each group. And if I do that, I can factor that in, throw it into my statistical analysis, and now I have a clearer picture of what is actually going on. Brings us to threats to validity. And there are 4 types that Creswell outlines. The first one, statistical conclusion validity, we're not going to spend a lot of time on because you just don't have the expertise to kind of evaluate this in research that you're using. And if you are going to use some statistical tests in your own research, you will probably want to consult with somebody who has a little more experience. But oftentimes you will have small samples. People will confuse statistical and practical significance. Again, statistical just means that it's unlikely to happen if there is no relationship between variables. And practical significance means that it is or is not a meaningful effect in real-world terms. There are things about standard errors, test assumptions, and scales of measurement and so on that we have talked about a little bit in the past when we talked about quantitative data analysis, but we're not going to go into much more detail here. The second one is construct validity, and what you're really looking at here are the instruments that are being used. So if you decide to use somebody's measure for depression or anxiety or post-traumatic stress disorder, you need to know whether or not those instruments have been validated. In other words, did they give you reliable and valid results? Commonly used measurements, right, are IQ tests, different types of personality assessments like the Minnesota one, or any of those, Big 5 personality traits measurement devices. those have all been validated and studied very well, and you should feel confident. However, whenever you are looking at literature, people who use different instruments, whether they make them themselves or use something that was used in another study, need to mention how it was validated and give you validity and reliability information. We'll get a couple examples of that during our walkthrough. The last two are the ones we care the most about. The first is internal validity. And what internal validity is all about is whether or not the conclusions about the cause and effect relationship are actually warranted. When we think about the impact of confounding variables, experimenter effects, and the placebo effect, we have some holes that automatically appear in any differences we see between groups, because we don't know if it was due to the treatment or if it was just something that happened by chance or because of something else. So that's what internal validity is all about. We'll talk more about what that looks like. Finally, external validity is about whether or not your results can be generalized to the general population. In other words, was there something about the setting, the procedure, or the participants that make it unlikely to be applicable to everybody? So, for example, with the Bobo doll experiment, right, they did it with young children. Does it apply across every age range? Would elderly people do the same thing? Probably not, although it'd be interesting to envision your grandma or grandpa hitting the Bobo doll with a hammer. Could be. Maybe they have a lot of pent-up frustration, and clown dolls are kind of creepy. So you never know. But the idea is that you have to think about who your population is that you were studying, who you actually sampled, and who you want to generalize the results to. If we're thinking about substance abuse, right, are therapies that are useful for alcoholics equally as useful for people who are addicted to meth or cocaine or any other substance? And I think in many cases, the assumption is that yes, they will be equally effective, but maybe not. When we think about internal threats, then, there are a bunch that deal with the types of relationships we see themselves. One is the history of the participants. Are there any things that happen during the experiment, in between treatments, in between observations, or even in their life before that it's going to have an effect on how those participants actually react? In other words, right, if I look at an intervention that's going on during the school year, right, and I'm doing that smoking cessation study, and I'm looking at it over 3 months, I have my random assignment maybe at the beginning, and I put people into counseling groups and educational groups, and then a control group. Maybe the control groups is people who don't want to, right? But in that case, I have a lot of stuff happening in that school over those 3 months, and the students go through stressful periods where they might be more likely to want to have a smoke even if they're trying to quit. They may get new friends, they may go through a breakup, they may try something else, right? In other words, there's a whole bunch of stuff that can happen that's going to change how people react to my treatment. Another one is maturation, meaning that some skills just develop naturally over time. And so if I'm looking at the effects of an academic intervention, for instance, it turns out that, well, people tend to get smarter even if I'm not teaching them anything specifically, right? So my intervention has to be somehow compared, or I have to figure out what part of the increase in scores, whether it's math or science or reading, is due to my intervention, and what part just happened naturally. Similarly, if you look at personality changes, right, in early childhood, then into the teenage years, then into early adulthood, there are some natural developmental differences between children in middle childhood, adolescence, early adolescence, late adolescence, young adulthood, and old adulthood that I really need to consider when I'm trying to think about whether or not my intervention was effective. And so say I'm trying to do a study on the impact of mindfulness on anxiety or controlling impulsive behavior. Well, adolescents have a much harder time controlling impulses than other people do because of the big hormonal shift in the landscape. And so I would need to consider that, well, if I'm doing, say, a 3-year study and I start with people in late adolescence and they go into early adulthood, I'm going to have a natural decline in impulsive behavior. So I need to think about whether or not that's going to have any impact. A third thing is statistical regression to the mean. Now, what this means is that sometimes in the pretest, I will have somebody who performs at the maximum level of their capability, or they get even lucky as well as performing at their peak, and they get a really high score. And then I see a decrease, and I think that either my treatment wasn't effective or that it had a negative impact on how well a student can do. Similarly, right, if say I'm measuring something like blood pressure, the first time somebody's getting this taken, I'm sure you have all had this experience, you go into the doctor, they ask you to put out your arm to get a blood pressure reading, and all of a sudden you feel like you're taking a test and your anxiety level goes up. They're just trying to get a reading. It doesn't matter, but I think most people's heart beats a little faster when somebody's actually measuring it, right? And then maybe if you do this every day, by the end of the week, you don't really care that much anymore, right? Your relationship to that experience has changed. Similarly, if somebody has very poor performance or very lower than average performance for them, they're probably going to go back up and get closer to their true average. And so I have to be careful about where my students or my subjects actually perform, how they perceive the event, and whether or not they had a reading that was atypical of what they would actually produce. A fourth thing is mortality or attrition rates. And this means that sometimes people leave your study. And sometimes that happens in a random fashion, and sometimes it happens in a non-random fashion. Now, if it happens in a random fashion, you're okay, because you're just decreasing your sample size and you're going to lose some statistical power, but you're not going to influence the nature of that causal relationship. However, if I'm thinking of a mortality situation with, say, some sort of medication where the weakest members seem to be dying, right, that's going to impact how I look at the effects of that drug. Whether or not their death was the cause of the drug, of course, is another issue altogether. But let's say that it wasn't. Right? I need to figure out whether or not these people who have left the study, whether it is by dying, choosing not to participate anymore, moving away, or whatever, whether or not that is going to influence and make my random samples no longer unbiased. Again, I randomize people because I don't want any bias in my samples, so I can have a clear picture of what happens with my intervention or without my intervention. When people start to leave, if people of a certain type start to leave, that's going to impact how that variance is split up among the samples. Fifth, selection bias. When you're looking for participants, right, in many cases, especially with psychological sciences, you get people who, one, need extra credit, two, are interested in psychology, three, like to please other people and just agree to participate because they think it's a nice thing to do, right? People who volunteer are different than the people who don't volunteer. And your question that you have to ask yourself is, are the people who, right, choose to be in this study different from the people who don't? And so is there something about the people that's going to make my intervention more or less effective from the population of everybody who I want to generalize it to? And so we can go back to the smoking article again, right? What they did in that article was they solicited not just high school smokers, but high school smokers who wanted to quit. Now, again, this intervention is going to be different for the high school students who want to quit than high school smokers in general. So they have to be careful about whether or not they think this is going to work for everyone, or whether it's just working for people who want to quit. Because, right, people who want to quit might have quit anyway. And so if I've had enough with smoking, I have health problems, my girlfriend or boyfriend doesn't like it, my parents are mad at me, and I just don't have money for cigarettes anymore, right? I'm at the end of my rope financially. I might just quit anyway, but I sign up for your study and I make you look good. And so you have to think, are the people who are in your study, and especially if they self-selected and you didn't have a random sample, right? Is any change that you observe actually due to what you're doing, or is it something that would have happened anyway? Now, any of these things can interact, right? History and selection and maturation can interact with one another, so you have to consider that as well. And then we also have to consider the placebo effect, which again, the experimental designs that have control, placebo, and treatment groups take care of this because you can actually measure the placebo effect. But the placebo effect, as we've said in class before, is something where just because you think you're getting a treatment, your physiology or your behavior changes. Not because of anything that the drug or the interaction or intervention did, but just because you thought it would. And again, this has been shown from everything to depression, to Parkinson's disease, to knee surgeries, and so on. So the placebo effect is really powerful. Sometimes it's even more powerful than the actual drug or treatment. It just usually doesn't last as long. Additional internal threats happen during treatments and procedures. Treatment diffusion occurs when treatment groups communicate with one another, and that is going to mess up your results. This is why double-blind studies are so important, so people don't know what condition they are in. And you, if you can, don't want your participant pools to be communicating with each other anyway, especially when you're talking about longitudinal studies. Other things that happen when groups can communicate are compensatory equalization. One is when benefits are distributed across different groups. It's harder to isolate the agent of causal change. You have also compensatory rivalry. And if one group thinks that they're getting something that the other group is not, they may become heated and antagonistic. Similarly, resentful demoralization. Again, if the control group feels like they're getting the short end of the stick, it may impact your outcome measures. And so you want to, and whenever you can, make sure that people don't know what's going on to some extent, as long as your IRB approves it. And you want to make sure that benefits are spread out to everyone who's involved in the study, if possible. In like medical studies, then you might have a different schedule of when people are going to be on different drugs. So you can look at, right, a 6-week process. Group A will get the treatment starting week 1. The control group B will get it after the 6-week trial is over. So you can look at apples to apples comparisons, but they're still going to get the benefits. They're just going to get it at a later date. When we think about instrumentation, sometimes you have changes to measurement devices or they're used in an inappropriate manner. Sometimes this is needed because what you're trying to measure actually changes, and especially if you're doing applied research, the real-world requirements of what is appropriate or inappropriate or motivated or successful are going to change over time. Finally, you have testing differences. Pre-test sensitization, meaning again that when I expose you to the pre-test, it changes what you're going to do on the post-test. And then also fatigue. If I keep having you do things over and over and over, you might get tired of doing it. So I have to make sure that I control for those different things. If we think about external threats to validity, again, this is anything that limits your ability to generalize results. I'm really talking about a lot of things that randomization and counterbalancing take care of. So when I think of selection bias, right, people who self-select are going to be different. If I accidentally draw people in a intentional way and put them into different groups, it's probably going to limit who I can generalize things to. People, again, who volunteer for studies are probably different from people who don't, especially in the social sciences, right? So I might not be able to generalize it to the whole population of smokers or addicts or people who are having trouble in school, right? I also have reactive effects, which is really about a lack of external validity between my experimental procedure and the conditions that I have in my study and the real world. In other words, yeah, it might be okay if I develop some kind of procedure or drug and you are in a pristine environment in which no outside factors are relevant. It's kind of like being on The Bachelor, right? Things that happen, whether or not the relationship will stand the test of time outside of the bubble of the mansion and the worldwide escapades, is different from when life and friends and family actually intervene. And for the people who watched last season of The Bachelor, you saw how family can put big pressure on whether or not a couple stays together. Fourth, you have ordering effects, and this is for multiple treatments. Sometimes the order in which treatments and controls are given will impact the results. And so typically when we talk about a counterbalance design, and say I'm giving two treatments, I may have one group go A, B, for my two different treatments. The other group might go B, A, and so on. Excuse me. Finally, I have interactions between any and all of these. Types of experimental designs. We have between group and within group as our major categories. Between group involve our true experiments, quasi-experiments where we can't really assign people to groups. We'll get to that in a minute. Causal-comparative research, which has even fewer controls. And then factorial designs where we have more than one independent variable. In the factorial design, we've already looked at some of these when we looked at ANOVA and the interactions, for example, between cheap and expensive chocolate and light or milk and dark chocolate, and how those two things interacted. For within group, we have time series experiments that are either interrupted or equivalent. We have repeated measures experiments, and then single subject experiments. Now again, the classic experiment we have is typically a comparative with a control group. Things are matched or blocked into different categories based on variables that we think might have an impact. A quasi-experimental design means that you have groups that you want to compare, but you can't really randomly assign. Again, we've talked about this a little bit in the past. And so if I want to compare men and women, I can't really make somebody a man or a woman randomly. And even if I randomly select for men and women, and I'm comparing the effect of a treatment on men and women, that random assignment and random selection doesn't really get around all the problems that it might cause. So in a quasi-experimental design, then I can do my non-equivalent control group design just like I had earlier in my true experiments. I can also do an equivalent time sample design where I give an intervention, then I take away the intervention, give the intervention, take away the intervention again, and I look to see how things change. In a pre-experimental design, I just don't have a control group. And so I can do all the other things that I want to do, whether it's cross-sectional, longitudinal, time series, or group comparisons. But I don't have a control group to compare people to. Now, there's one notable kind of boundary example here. So pre-experimental designs typically involve single group, post-test design. I could also have multiple treatments, so I could be comparing across treatments. I just wouldn't have a control group. I could have a single case study where I give a treatment and look at some kind of observation without a pretest. Or I could have a static group comparison where I look at some people who got the treatment and what they're like, and people who didn't get the treatment and what they're like. Again, in this case, there is no pretest, and so there is no real control regarding the effect of the treatment on each one of the groups. In a causal comparative design, I can, again, do whatever I want to do in terms of groups or over time, but I have no random assignment and I don't have any manipulation. I'm not controlling anything. Whatever treatment or impact variable I'm looking at has occurred naturally and likely in the past. Even if I am able to find strong relationships between variables, again, it's really hard to identify a causal relationship. So, for example, a difficult case would be drug use and absenteeism from school. Now, it could be that I would find a very strong relationship, and actually research has found a strong relationship between these two examples. But the problem is we don't know if drug use causes absenteeism or absenteeism causes drug use because, idle hands and the devil's workshop and all that stuff. Or there might be some outside factors that attribute or cause both of these things. Or they might interact on one another. Likewise, I already talked about the parental style and child adjustment idea. It might be that, authoritarian parents lead to behaviorally defiant children, or it might be that defiant children cause parents to become more authoritarian. Finally, we might have a case where we can actually figure out what the causal relationship is. In the case of sun exposure and skin cancer, right? I don't randomly assign people to groups to be bombarded with ultraviolet radiation. I'm not controlling that. I'm just looking at people and kind of working backwards to what do people have in common who get skin cancer. And we find a very strong relationship to sun exposure and skin cancer. And in this way, we can infer the causality or the direction of that relationship, because it doesn't make any sense to say that having skin cancer would cause you to have gone out in the sun more in the past. That doesn't make any sense. So sometimes we can figure this stuff out. Finally, we have single subject designs, which are very useful in both counseling and special education, and basically what you do for each case. The author spends a lot of time on this. Again, I don't think that there's that much to it in terms of figuring out what you need to do, but the essentials are you do need to establish some kind of baseline behavior. Secondly, you need to have some kind of intervention to figure out whether or not it's going to impact the dependent variable that you measured in the baseline. Third, you need to have more observations after the intervention to make sure you can see what changes while controlling for different environmental factors. Finally, replication is required for confidence in your results. So just looking at one person, right, doesn't really allow you to make claims about a causal relationship, because there are so many other factors, threats to internal validity, that were likely going on. If you can repeat this, though, with multiple people, you can start making a case that actually the intervention is effective. I also do want to note that there is a typo in the text. When they're talking about the ABA design, they, I think, say they do baseline intervention and then another intervention, but it should be that there's no intervention. And so you can see what happens when you take that intervention away, if the changes that you saw are sustained or if they go back to baseline. Some other confounds and experiments that we need to think about in a broader sense are the Hawthorne effect, which is this famous study about the impact of being observed, and that they wanted to know if different changes or policies implemented in a factory changed worker productivity, and so they had a bunch of people observing the workers. Well, of course, that changed the workers' behavior, but it wasn't because of the changes in the policies. Second, we have the placebo effect that we've talked about before, and there's a great radio lab that I'll send a link to that you can listen to. Very interesting about how shaman have their little tricks, how doctors and hypnosis works, and all sorts of interesting stuff. Fascinating listen. Third, we have demand characteristics, which are basically cues from the researcher or the observer that leads the participant to do what you want them to do. And the most famous example of this is a story about a horse that purportedly could add. And so you would give it a problem that would stomp its hoof multiple times to tell you what the right answer was. So you'd say 3 plus 4, and it'd stomp its hoof 7 times, and so on. And so they'd have all sorts of people come and see this horse do this. Well, it turned out that the horse couldn't add, but the horse was really good at reading people and would keep pounding its hoof, and people's eyes would get wide, and then when there was some indicator that they got to the number, then they would stop. So that's what was happening with the horse example. Likewise, cases of leading the witness or giving people cues about what you want them to do rather than just being an unaffecting observer can lead to demand characteristics in all areas of life. Other internal threats to validity can be included here as well, and we've talked about all those in much more detail. Now, there are 3 useful tables in the chapter that I think will be very beneficial to hold on to going forward. One is what's involved in the different types of experimental designs, right? And so you have random assignment, whether it happens or not. And again, it only happens really in a true experience, although it can be used in factorial. Factorial can fall into any one of these. We have number of groups, right? 2 or more. Time series actually can have more than one group as well. Number of interventions used. Number of times the dependent variables are measured. There's more flexibility in this, and these can all be combined. We'll look at some examples of what that looks like. You also have multiple measures in many cases as well. And then controls used, typically pretest, matching, and blocking, which are kind of the same thing. And then covariates. Blocking usually means putting people into different groups. Matching means making sure that the people in those groups are matched on additional abilities. So if I split people into male and female groups, I want to make sure that, say, the IQ or the income or the education or the adjustment of all the men and women are the same. And I will match a male who has, say, high income, high education with a female who has high income, high education, and so on. So in that case, note that in single subject designs, you are limited by most things, right? Individuals become their own control. Sounds like a terrible idea, and a lot of times it is, but that's why you establish a baseline, right? Typically you have multiple interventions, and again, you are looking at one person who was picked intentionally. The second table are the threats to internal validity. And when we look at, right, how a true experiment controls all these things by its random assignment and its control group, right, we get rid of a whole bunch of possible threats. In quasi-experimental, because I don't have random assignment, it all becomes a potential threat. In causal-comparative, right, I have even less control, potential threats. If I'm using a factorial design and I'm doing an experiment with a factorial design, then I have control. Time series, I can get control over most of these things, but I have to be careful about how I set up my procedures. In repeated measures, depending on the interval, history could be a problem no matter what I do, if it's a long time, but otherwise it can control for everything. Single subject, again, I have a potential threat in history. I don't think, in this case, I disagree with the author here, that the single subject controls maturation. Unless you are looking across multiple single subject studies. I strongly disagree with that. Regression, because you're typically going over many different data points, that can be, but because in some cases single subject designs don't have that many data observations and there are seasonal changes or major events in the year that cause different types of regression. I would disagree with this too. Selection, because you're picking somebody out, I have a feeling that that's not controlled either. Mortality, that is kind of controlled, because if they leave the study, it's over and you have to start from scratch. So it's kind of controlled in that way, and I disagree that this is controlled as well. So I feel like there was a copy and paste error here. I disagree that these are controlled in meaningful ways. When we think about other procedural threats, right, I have my testing and instrumentation. Depends. I disagree here because of experimenter biases and selection biases and things like that. But ultimately, these are things that you can get around. In terms of testing, right, you want to make sure that you control for any pretest sensitization or fatigue, and you can do that across all of these. For instrumentation, you need to make sure that the measures that you use stay the same, and if they change, there is a good reason for them to change, because they better reflect the changing landscape or how success or failure is defined at the later date. Now this brings us to our last slide, which is really all about how we're going to evaluate research articles and how you're going to apply this to the assigned research article, how you're going to convey what you found back to your fellow classmates. So that all being said, the next video will walk you through this grid and take you through an example.